Okay, so for problem number 1, it says find the equation for the function that is finally graphed after the following transformations are applied to the function y equals x squared in the order listed. Okay, so the day that you guys were taught this lesson, it was actually the day that Andrea from Muncie taught the lesson over transformations and translations. And a couple things you want to notice or pay attention to. They did tell us to use y equals x squared. So when I go to write my new function on the line, I'm going to go ahead and start with y equals. And then I want to talk about b and c first because you guys have actually practiced doing that on the lesson that Andrea taught you. So if it says to shift down 4 units, is that your vertical shift or is that your horizontal shift? That's your vertical shift. And your vertical shift goes on the outside of the parentheses. So normally what happens here is we'll have a set of parentheses with a squared outside of it. We always have x inside. But like Jessica here in Richmond just said, the down 4 is your vertical, which goes after that set of parentheses. So would I put -4 or +4? You put -4 because you're shifting down. So this one right here, since it's the y shift, it is always at the end, and you always keep it the exact same. Okay, so that right there should be review. We've done that before. Now, letter C is also review. This one says to go left 6. When you're going left or right, that is your x shift. And your x shift always goes in the parentheses with the letter x. But does it stay the same or go the opposite? It becomes its opposite. So right now, when you guys think of left 6, you think -6. But since we always have to make it its opposite, we're going to actually change it to +6. Now that right there, you have done before. You did it that day when everybody practiced together. The only different part is letter A. And if you guys think about this, anytime we have a quadratic, which would be a parabola, I'm just going to draw a little sketch over here. If it's positive x squared, isn't it facing upward? Like I just drew? Yes. Okay, so if they want you to reflect this about the x-axis, just think about what would happen. Like if my x-axis is here, and they want you to reflect it over the x-axis, aren't they telling you to flip it upside down? Yeah, they're telling you to flip it upside down, and when they tell you to flip it upside down, I'm going to just try to draw this one dashed. It's not turning out very good. If they tell you to flip it upside down over the x-axis, wouldn't my parabola just become negative? Because it's facing downward. So the only other thing I need is a negative sign out front of it. And then that problem's finished. So if they tell you to reflect about the x-axis, if the original parabola had been negative, wouldn't I turn it positive? Yeah, you just make it its opposite. But since it started out positive and we're flipping it upside down, that's why I had to put that negative sign out front. If you feel better and you want to have a number there, you can put -1, but you don't have to have a number. You just have to have that negative sign. Okay? Feel okay with that one? That one really is, it's not entirely new for you. 2 of the 3 transformations we've done plenty of times. It's just that first one that I don't think we ever really practiced doing that, but you guys should all understand the concept of a regular parabola, positive is always facing up, and we know that negatives would be facing down. So, problem number 1 is done. And then if you look at the rest of the first page, 2, 3, and 4, we've done plenty of problems like that before throughout the term. So then if you turn the page over, I did kind of group 5, 6, and 7 together because 5, 6, and 7, even though we've done problems similar to them, there are just slight little things that make them a little bit different than what you've seen before. So go ahead and turn the page. And we'll do problem number 5 next. This one takes quite a bit of time. Okay, so when you look at problem number 5, what I notice is I have x squared plus 9x plus 14. That's a quadratic. And normally it says equals 0. We haven't really dealt with quadratics that are inequalities. Okay? The good news is that the very beginning of the problem, we are going to solve that for x just like we always have. Let's just pretend like it's an equal sign. And let's solve the quadratic. And you all should know that in order to solve a quadratic, it has to be set equal to 0. And good news, it already is. So we don't have to move anything around. So let's just pretend like it's an equal sign for now. And what this is going to do is this is going to give us some boundary points that we'll have to test here in just a minute. But what would you guys do next to... Yeah, I would do an asterisk problem. You have a 14 and a 9. So two numbers that multiply.
7 and 2.
Yep, to make 14 and add to make 9 are 7 and 2. Okay, so now we have our two sets of parentheses, x plus 7 and x plus 2 equals 0. So then if I told you to go ahead and solve those, how would we do that?
Set them both equal to 0.
Yep, set each one equal to 0 and solve them separately, giving us two negative answers. So we have x equals negative 7 and x equals negative 2. Okay? Now if that truly had been an equal sign, those would be our two answers and we would be finished. However, what we have just done right there is we have found our boundary points. Okay, so those are boundaries. And what we're going to do with it is I'm going to draw a number line. And I'd like you guys to just put like negative 7 further to the left, and we'll have negative 2 further to the right. And if you look at that number line right now, how many sections is it split into? It's split into 3 sections. You've got one section here, so less than negative 7. You've got one section in the middle that goes from negative 7 to negative 2, and then you've got this other section that's greater than negative 2. Okay? What we have to do is we have to pick a number in each of those sections, so any number that falls to the left of negative 7, we can use any number that falls between negative 2 and negative 7, and then any number greater than negative 2. And we have to test each of those points to see which numbers are true for this inequality. Okay, so pick a number less than negative 7.
Negative 4. Oh, sorry.
It's okay. Negative, let's try like negative 10. Okay, we'll try negative 10. This is going to be the point that we're going to test here in just a minute. And then a number between negative 2 and negative 7, let's go with, I don't know, like negative 5. You could use negative 4 there if you wanted to. And then greater than negative 2, I'm going to use 0 because 0 is always a really nice number to always just do a plug and chug with. So you have to pick one number from each section, and we have to test it to see if we plug it into our original inequality, will our answer truly be greater than 0 or will it not be? Okay, so what I do is I plug it into these two sets of parentheses, and I check to see, is my answer greater than 0? I like to plug it into the factored form. You could plug it into this form up here. I just think the math is easier if you plug it into the factored form over here. Okay, so let's start with a negative 10. If I plugged in a negative 10 right here and right here, what would be inside both of those parentheses? Like, what is negative 10 plus 7?
Negative 3.
Negative 3. And what is negative 10 plus 2?
Negative
negative 8. Would that answer be greater than 0? Well, what's negative 3 times negative 8? Positive 24. Is positive 24 greater than 0? Yep, so that one is true. Okay, so anything less than negative 7, including that negative 10, those would all be true. Those solutions would all work for the original inequality. Okay, now let's try in the middle section. So let's try negative 5. And now we're going to plug negative 5 back in over here like I just did with the other two. So what's negative 5 plus 7? Positive 2. And what's negative 5 plus 2? Negative 3. Will that be greater than 0? What's 2 times negative 3? Are negatives bigger than 0? It's okay. You have all the pressure because you're the only one here with me. So 2 times negative 3 is negative 6, and negative 6 is not greater than 0. So that middle section, any number that would fall between negative 2 and negative 7 would give us false answers. Okay, that's what that means. So then now we have to try the 0, because 0 is the number I'm using to represent all numbers greater than negative 2. So if I plug in zeros to those two sets of parentheses, what's 0 plus 7 and 0 plus 2? Is that answer going to be greater than 0? 7 times 2 is 14. 14 is definitely greater than 0. So we have two sections that represent all of our solutions. All of our solutions, I'm highlighting them right now, would fall either less than negative 7. It can't equal negative 7 because negative 7 would make it equal to 0, and they said it has to be greater than 0. So anything less than negative 7 works, and anything greater than negative 2 works. The only section or the only numbers that would give us false answers are the ones that are not highlighted up there, so they're the ones in between negative 2 and negative 7.
So what if the other side was 0? Would it still be?
What do you mean, what other side?
Like where the 7 and 2 are, like what if that equaled 0? What if it was something that equaled 0?
Well, okay, so if it said, if the statement was 0 is greater than 0, that would be considered false. Because it would have to have the equal sign for that to be true. Okay? Now, the only thing we have left to do on this problem is to write our solution using some kind of notation. Now, this is probably a notation that you guys have not seen before. You may have actually seen it when you took AccuPlacer, but they want us to show all of our solutions in interval notation. So what that means is we need to show where all of our solutions lie. So we said it's anything less than negative 7. So the way we do that is we say from negative infinity, meaning all negatives, leading up to negative 7. So that's our first interval. Our first interval is represented by negative, it's really hard to draw an infinity symbol on here, negative infinity to negative 7. And then to show, you draw like this U shape there in the center. That's like union with. So that just basically means and. It's the answers on the left and the answers on the right. Okay? If we want to say negative, anything greater than negative 2, we're going to start at negative 2 and go to positive infinity. So that is the proper interval notation. Ways you would have written that before is anything less than negative 7. You guys would have just put x has to be less than negative 7. And then to show greater than negative 2, you would have put greater than negative 2. What I just wrote in the box is the exact same thing. It's just a little more advanced. It's something that you would definitely see more at the college level because it's what we call interval notation. So they want to see that all negatives work leading up to negative 7 and that The rest of our answers fall from -2 to all of our positives. So whenever you see negative infinity, that just represents all of your negatives that exist, which there's an infinite amount of them, which is why we use infinity. And same thing with positive infinity, that just means all of your positives that exist. Okay?
Melissa,
Yes.
I have a question.
Yep.
Did you answer for the students? If it had greater than or equal to 0, how would that answer change? Maybe you said that, I missed that.
Well, so my student that's here with me had asked, like, if right here, if this side, when she tested a point, if that had said 0 is greater than 0, she wanted to know if that would be true or false. And I told her it would be false because it did not have an equal sign.
Okay. And what if the problem had greater than or equal to 0?
Well, we would, when we test it, if it said greater than or equal to 0, you could also, I mean, you would definitely include both of these because both of those are greater than 0. And then if one of them happened to be equal to 0, that would also work. I don't know if that just answered your question or not, but.
Would you write your answer differently in that case? Would it be a square bracket on the 7 and the 2, -2?
Yeah, so the open bracket right here, well, it's an open parenthesis. That means that it cannot be included with the -7 and the -2. So yeah, if by chance they had an equal sign there, then we do a more square bracket. And that would just show that you're including -7 and -2. So yeah, if you guys happen to have an equal sign there, that's the difference between that regular parenthesis that you normally see versus the bracket. Good question.
Thank you.
Hey, thanks for helping me, Scott. Okay. All right. There we go. So that problem that you guys would expect to see on your Ivy Tech final, you're going to run into some just like this where, well, actually there's only one like this, but you're going to have to go through the whole process of finding your 2 boundary points and then testing 3 different numbers to see where all of your solutions lie. Okay? I do think one of the practice links that I sent to everyone today, and I scanned more material, there are more problems like this. So if your students want some extra practice, then you could just print off the practice for quadratic inequalities, and then they can practice them on their own time. Okay, because the Ivy Tech final is not scheduled until Monday, June 3rd. That's when I plan on giving it to my students. So you guys still have from now until almost it's over a week away. So you have all next week to still prepare for the Ivy Tech final. Plenty of practice time. Okay, number 6. All right, so problem number 6, right now when you look at it, it definitely has the looks of just an exponential equation because you have an exponent. If I were to tell you or ask you right now, like, what do you think the first step in this problem would be? We always have to try to get the base by itself. So what number could I move? I could move the 4. So if they have multiplied by 4, what do? We divide by 4. Okay, so we have 8 to the power of x minus 2 equals, now I'm going to ask you guys to put that, just leave that as a fraction. What is 46/4? Like, can it be reduced?
Yeah, it can.
Because they're both even. And anytime you have two even numbers, I can just cut them in half, right? So this one would reduce to 23 halves. Okay, so if you want to make a note, I'm just dividing both of those by 2. Okay? Now, when I look at this problem that I've written down in purple, the exponential equation, they're not going to come right out and say, hey, don't forget that when you have exponentials, if you need to solve for something up there in that exponent, we usually turn it to log form. That's what we created logs for. It's just something that you're going to have to remember. So right now, if I say, let's take this exponential equation and let's write it in log form, how would we do that? I'd write the word log. My base is 8. Yep. 23 over 2 equals x minus 2. Perfect. Now that, even though it looks a little different than maybe something we've done in class together, you guys have all taken exponential equations and written them in log form. You were just tested on that. So what I just wrote there hopefully looks familiar. Your base was 8. The y value would be the 23 halves, and then you always set it equal to the exponent. Now, if I'm just telling you to solve for x, what's the only number I need to move? The minus 2. And how do we move a minus 2? We add 2 to both sides. And this is going to be your final answer. I'm not going to combine the log with the plus 2. I'm just going to write it all sideways. I'm going to write the log. So log of 23 halves with that base of 8, and then after it you're just going to put plus 2 equals x. And that's as simplified as it needs to get. So that is taking an exponential equation, turning it into log form, and then just isolating your variable. Isolating your variable took one step. We just had to move the minus 2 to the left side by adding it. Now our final answer there definitely looks very different than what we've gotten in the past, but the steps before it you guys have all seen. So really the only difference is just adding 2 to the other side and then stopping. And there's only one of those on your Ivy Tech final. It's going to be very similar to this one. Hopefully by now everybody's noticed that I always try to give you a practice test that looks almost identical to your real one. It's no different with the Ivy Tech final, okay? I want you guys going into this as prepared as possible, so. All right. Any questions on that one? If any of the other schools have questions, please ask. I've got one student here with me, so she's feeling a lot of pressure right now to answer all my questions. She's scared she's going to get it wrong. Okay, now, number 7. That does not say in. That's not an IN. That is an LN. Now that is a kind of log. It's something that we actually call natural logs. And the reason I put this problem is because when I taught you guys logs, we didn't ever talk about natural logs. That is something that's more focused on, I think, maybe pre-calc, when you get a little bit above Algebra 2. However, the good news is natural logs essentially have the exact same properties that logs do. Okay, so even though you're seeing this different log up there, you see LN instead of the word log, we still use properties the same way. Okay, so when you guys see addition on the right-hand side, what do we normally do to condense it? I'm sorry, what'd you say? You multiply. So my left side stays the same, and then the right side, I'm going to multiply those right there. So you'd have to distribute, right? Mm-hmm. You'd have 4x minus 4. And now we can just set the two expressions equal to one another. There is a little bit of extra work in there that I skipped, and it has to do with like a base E. I try not to go too much in depth with that just because throughout Algebra 2, I never even taught natural logs, and I really never talked about base E. There's lots of things online, like if any of you guys who are dual credit students, if you're really interested in learning more about natural logs, you can Google it. You can get on Khan Academy. There's all kinds of tutorial videos. But at the end of the day, they follow the same properties. So as long as you're comfortable with addition being turned into multiplication, you can do this problem essentially the same way we do regular logs. Okay, and then how would we solve that equation?
Subtract 4x.
Subtract the 4x. Negative 1x equals negative 4.
And divide by 1.
And if you divide by negative 1, x becomes
Positive 4.
positive 4. So if you want to make a note on here, you could say your natural log follows same properties. So if that had been a minus sign, we would have turned it into division. It follows same properties as log. Okay. And then problem 8 does not have a star. That's just a grouping problem that you guys have done plenty times before. So I'm going to skip over to number 9, and then I think we have one more after that. So we've got 9 and 16, and then that'll wrap up the starred problems. Everything else on the final is something that has already been taught during this term. It's really nothing brand new. Okay, so number 9 asks you to find domain, range, and asymptote of the given function over to the right. So notice it's a log function, and we talked about asymptotes yesterday during the second part of class. So we're going to start with domain, and I mentioned to you that when you're dealing with logs, the number in here, when you go to take the log of something, it can't equal 0 and it can't be negative. So to find the domain, which always deals with your x values, that just means that this x minus 1 in the parentheses would have to be greater than 0 because it can't equal 0 and it can't be negative. So how would I solve that inequality right there?
Add 1.
I'd add 1 to both sides, and wouldn't that just be x has... I almost wrote greater than 0. That just means x has to be greater than 1, right? Well, you just found your domain. So my domain is x has to be greater than 1. So for domain of a log, always set whatever's in parentheses, put that it has to be greater than 0, and then just solve that inequality. Should be a pretty easy one every time. Now your range, I almost wrote the answer.
All real numbers.
Yeah. How did you guess it was all real numbers? So your range is dealing more with your y values. So even though the value of x can only be greater than 1, your y values can really be anything, because even though right now that one says plus 4, if there had been like a minus out there, technically your answer could go negative. So your y values can be anything, any number that exists. So for range, anytime they ask you for range of log, we always put all real numbers. Now, I enjoy drawing that symbol for all real numbers, but of course, you could also write it as this notation. Because if I say it's going to go from negative infinity to positive infinity, that means all real numbers, all numbers that exist. So I like to draw the fancy R. I'm guessing that interval notation that I showed out to the side, that's probably a little bit more college level than drawing that symbol that I draw. But, I mean, personally, I would accept either. And then for the asymptote, clearly there's not a horizontal one. There's not a y equals anything because we just said y has no limit. Like we're allowed to get any value for y. But there has to be an x asymptote because we just said that x has to be greater than 1. So there is a vertical asymptote. And it's just going to be the exact same thing you have for a domain, except it's going to have an equal sign. Because remember the asymptotes we did yesterday, vertical asymptotes were always the equations that said x equals a number. Like yesterday it was whenever it made the denominator 0. Well, this asymptote is whatever is going to make this what we're taking the log of. So like x minus 1 equals 0. That's how I got the x equals 1. So your domain and your asymptote for logs always look pretty much the same, except your asymptote will have an equal sign. The domain will have a greater than symbol. But the number will be exactly the same for each. And then range is always all real numbers. Is everybody okay with that? Everybody out there in all the other 4 schools that I'm talking to? I am going to mention one thing about, oh, yep, hello.
Yes, we're okay.
Oh, okay, thank you. I'm going to mention one thing about number 10, but I'm not going to work out number 10. I just remembered that number 10 asks about slant asymptotes. You can also refer to those as oblique. I didn't teach those yesterday. The only time any problem like that is going to have a slant asymptote is if that top degree is bigger than the bottom. And we don't usually deal with problems like that, at least not at this level. We haven't had any. So most often on problem number 10, when you guys are trying to work that one out on your own, find your vertical, find your horizontal, just like we did yesterday. And when it asks for slant, just say there isn't one, because that top degree is not larger than the bottom. So we don't have to worry about slant asymptotes. Okay, so I wanted to point that out. So you could go ahead and write that down. But you will still be expected to find your vertical and horizontal. Okay, last problem, number 16, and then you won't have to listen to me much more, at least not this week. Problem number 16 is really not much different than other problems we've solved by factoring using the asterisk. It looks a little bit different because you see x to the 4th. But notice how it's x to the 4th, then x squared, and then a constant. So when you see a problem that says list all possible rational zeros, I treat this as an asterisk problem because watch. I can still do a times c, which is 64. I can still put b at the bottom. And normally here and here, we would take x squared and cut it in half. That's why we have x and x. Well, if it's x to the 4th, what would I put on each side? I'd put x squared on each side. Okay? So if you need to, look at your factor sheet. Try to find the 2 factors that would multiply to make the 64 but would add to make negative 20. Negative 16 and negative 4. Yep. So normally when we write our 2 sets of parentheses, it would just say x minus 16 and x minus 4. Well, now it says x squared minus 16 and x squared minus 4. And once we have our two sets of parentheses, don't we just separate them and solve each one independently of the other? So I would do like x squared minus 16 equals 0, x squared minus 4 equals 0. So what would I get on the left? I'd have x, or what would I do with the minus 16, sorry? Add 16. That step is no different. It's just this last step that's going to be a little different because normally we see x equals 16, but now it says x squared, so we do square root, and square roots can be both positive and negative, right? So I would put x could be plus or minus 4. And I'm going to do the same thing with the other one. I'd add 4. And I'd get x squared equals 4. And then I'd finish by taking the square root. So what's the square root of 4?
Plus and negative 2.
Yep, positive and negative 2.
I don't know why I say plus.
Well, I say plus or minus all the time. Positive or negative, plus or minus. But so this one has 4 different zeros, right? It could be positive 4, negative 4, positive 2, negative 2. So even though it was a different power, the degree was a little bit higher than what we're used to, you can still treat it like... Okay, so those are the only starred problems that I have. Everything else, like I've gone through and I've worked them all out. I have scanned and sent answer keys to all the facilitators. So at any point in time, as you guys are kind of working on these independently, if you have questions or if you just want to check and see if you got a right answer, your facilitator there at your individual school does have a copy, and I have worked every single problem out in a way that you've seen me work them all out before. So there really shouldn't be any kinds of surprises. But as far as this IB Tech final, I would like you guys from now until the middle of next week, focus more on your Algebra 2 final because that's what you're taking next week on Wednesday. At least that's what we're doing here. And then next Thursday, so a week from tomorrow, it seems like forever away. Next Thursday, I will go through the rest of the Ivy Tech final or practice final problems. So all I ask is that at some point before next Thursday, please try to have all of the problems that are not starred done. So that way next Thursday as I'm going through them, you guys can check to see if you did them right or not. Okay? All right, so I am officially done for today. It's 2:02. Use the rest of your time today wisely. You guys can make things up, do corrections. You can work on your practice finals. And then I had intended on not connecting tomorrow just because I would like all students to have some just independent practice time. And a lot of my students don't have much time outside of school to work on these. So we're definitely going to use tomorrow as a working day. But that doesn't mean don't show up. Okay, everybody's still expected to be in attendance tomorrow to get some questions answered that you may have or just to actually have some time to sit down and practice and not worry about it outside of school. Okay, and then other than that, next Tuesday we will definitely reconnect at the beginning of class and we'll work through the Algebra 2 practice final together. Have a great long extended weekend, since I probably won't talk to the rest of the schools tomorrow. No, but we're just not connecting tomorrow. And enjoy your Memorial Day off.
Thank you.
Thank you.